All right, everybody, welcome back to the channel. Today we've got an interesting conundrum. This is an Aeroflex Weinschel Programmable Step Attenuator. It costs about 12,000 bucks. It takes 2 microwave signals and you can program it to attenuate them by up from 1 to 120 dB. This is really useful for programming our resonators at a variety of powers. Unfortunately, it stopped working. Some of the steps seem to have broken, so I think there's mechanical relays and some of them are not switching. We called the manufacturer and asked how much it would cost to fix, and they said it would cost $10,000. A new one costs $10,000 or $12,000. So this is is worthless. So we're going to try to get in there and see if we can fix it. Will this work? Who knows? But we'll give it our best. First thing we're going to do is power it up and figure out what is broken. Okay, I've already set up our network analyzer. I've calibrated it so that we have a through calibration. And so what I'm going to do is now hook this up to the step attenuator, and we're going to measure what it's doing to the microwave signal. We'll start with channel 1, and we'll hook up channel 1 here. We want to have the out port 1 hooked up to the input, and port 2 hooked up to the output. Okay, you can see when it's off here, it's attenuating by about 11 dB. So now I've got it set up so that we're dividing the memory trace by the current trace. And so what this means is that this will show us the attenuation that we're getting. So we have 0 dB when we're on 0. We go up to 1, nothing happens. So there's definitely something wrong with the transition from 0 to 1. We go to 2 dB and we get about 2 dB. So 2 dB is working, 1 dB is not. So I would especially expect 3 not to work, because 3 is probably a 1 dB plus a 2 dB. And so, yeah, we're -2, it doesn't change. Then 4 dB works. So I'm taking notes on this as we go. 5 won't work. 6 works. 6 is only triggering the 2, actually. So let's go. So you can see we're going 0, 1 gives us 0, 2 gives us -2, 3 gives us -2, 4 gives us 0. So I'm going to write this down. 1, 2, 3, 4. Okay, so it looks like we have several failed attenuators on channel 1. Let's now move over to channel 2 and see what we got. 280s are working. Nope. So one of the 40s is busted. So this is incredibly broken. I thought there were only a couple things broken, but it seems like at least almost half of the switches have failed. So let's get in there and see what's going on, but not looking super promising right now. All right, let's get started. All right, so what do we got? Power entry to a high voltage power supply. Well, we'll see how high voltage. There's a power supply here. This is the, on the back side, we have some dip switches for setting things. We have serial and GPIB communications. So this card here is a National Instruments, has National Instruments chips in it. So this must be some kind of GPIB controller here. It looks like all of the exciting stuff is on the back side of this. So why don't we take off the back? All right. Well, this is pretty simple. We have our input signal comes here. Then we've got this attenuator, which is a DC to 18 gigahertz, 12 volt attenuator. We've got another, and then, so this is a, each one of these goes to like 60 dB. And so stacking them together gets you the full thing. So there is a, So there's a bunch of switches in here that make everything work. The bad news is it's completely sealed. So, you know, it could be the driver circuitry that's driving these, but I really doubt it. I really think it's probably the switches inside. So a quick trip to eBay shows that these attenuators modules can be had for $200. I'm a little worried about whether they're going to work, whether there's something unique about our setup here. But that is definitely one possibility. So I think AT1 is the one that has the most dead attenuators on it. So I think we'll take it out and we will actually go and see what we can make happen inside of it. And if not, we'll try to buy some replacements. So I'm going to mark this as 1, mark this as 2, mark this as 1, mark this as 2, just so I know to put 3 here, just so I can figure out where everything was coming. And now let's take out number 1 and see what we see. To actually free it, I think we're gonna have to take off this plate. So I think we have to take off both 1 and 2. Now it looks like it's held in by a couple, this plate looks like it's held in by a couple screws. So we'll try to take those out. All right. We can now take this off with these 2 screws in the back. So let's go something like this. Let's see. All right, here is the part. All right, so it looks like the only fasteners are these 4 socket cap screws on the ends. So let's start with those and we'll go from there. Little mesh for keeping the RF in, I guess. Okay, what do we got? So there's some drivers on here. I don't see anything that looks fried. Got tantalum capacitors. There's no electrolytic caps on here that might be obviously dead. So these are the switches. Each one of these relays here, I think, must have some. It's going to do some kind of actual switching. I don't know if we can get in there. It's hard to say which is the, which is 1, 2. It's probably like 1, 2, 4, and 10 or something like that. Maybe there's only 4 relays in here. All right. So I think the next thing to do would be to like power this up out of the box and see if we can see the working ones actuate to try to figure out how it works. This is probably some kind of solenoid that pushes something down to make a connection. We can then look on the oscilloscope and see if it's getting the signals at each one of these pins. So I think that'll be the next thing to try. So I've got the module out. We're ready to get started on testing it. So I'm going to turn it on. It's powering up. It's doing something. All right. So now it's got all of these attenuators set. So I'm going to try to look at this while it goes and see if I can see any of these actuating.
These guys, oh, that one just went. Oh, that one just went. Okay, so we're at 0. All of these seem to be pulled out now, except this one, so stuck. Well, that's probably, you know what? That's why we were seeing 10 dB when it was just on. This one must be like a 10 dB attenuator, and it must be stuck on. So I can see it now. Let's see. So we're at 1, we're at 0, 1, 2. Must be doing something in this one. Oh. I'm gonna go till one of these does something. I heard a noise at 20. Okay, this one is, they're still all out. Oh, that one just triggered. That's 40. All right, so this one seems to be 40 dB. Up, that one triggered. This is 80. This is another 40. So these must be two 40s. Okay. So this one and this one never changed. Yep. So this one and this one, no matter what happens, do not change. So that is our problem, part of our problem. So let's see what we can do here. First off, I'm wondering if we can, this one just seems stuck shut. So it's possible we can just get in there and lever it open. Maybe it's just got something that doesn't like. Yep. Now it's open, now it's closed. Okay. It seems to move without too much resistance. Let me check one that's working, see if it's hard to push down. It seems about the same. Okay. Okay, let's see what happens now that I've given it a little bit of a free rein. Let's see if we can get that guy to trigger now that I've freed it. Oh. Okay, now it's down. Let's see if we can get it to trigger. Nothing. All right, let's try pushing this one in. See if we can get it to go the other way. Oh, it triggered. Now let's see if it goes the other way. Nope. It just, it stayed the way we set it, but not doing it, not changing it. Okay, that one pulled in too.
Okay, so what we've learned from this is that these, it's some kind of solenoid that is controlling these, and the solenoid is getting signals because we saw it change. When I put it out, it would get sucked in, but it's only going one way. So there's some kind of excess force it's not doing. The solenoid's not strong enough to pull one way or the other. So I guess what we can do is take out these screws and see what happens. All right, so this is, this has a big permanent magnet right here. This permanent magnet must be part of the solenoid actuation. Okay, so now we can see what's going on in here. It's got a little screw at the back. Need a smaller screwdriver. That screw looks like it comes pre-stripped out from the factory. All of them are fairly stripped. Let's see. So this is this is really simple. It's just a coil of wire. So it's not clear what the problem is. Basically, this, you can see that it's pushing. There's two pins that are getting pushed in by the solenoid that are basically making an RF connection. They're like spring-loaded pogo pins, and they're getting pulled out and pushed in by the solenoid. It feels, I would say by hand, it feels like the ones that are stuck are a little bit harder to actuate. I think what I'm going to do is get some electrical contact cleaner and spray these things down and see if that makes it easier for it to actuate. So it doesn't seem like it needs that much force, but it seems, since the coil's intact, I guess the next thing we could do should be to check to see whether we get a voltage pulse when this guy tries to actuate. So I can get the oscilloscope and hook it up to this, and we can see if we get that voltage pulse. And if we do get the voltage pulse, then, and the coil's intact, then it seems like it's got to be some kind of excess force issue. All right, I've got an aeroduster and some contact cleaner. Let's see what happens when we first blow this out. All right, let's try to reinstall the magnet and screw the solenoid in and see what happens. Right, we put the magnet back in. Now, this should, board's a little wobbly because we got to put in these these screws that hold the solenoid in. Okay, that is this guy right here. Okay, so now this seems to be back in place. Now let's see if this will actuate manually. Yep, it's out, in, out.
I feel like it's a little harder to actuate than the other one still. That might be an alignment issue. Where the pins that are going in and out are not as easy to get to. Let's ease and see what happens. Loosen this up a little bit. All right, let's see what happens when we power it up. Okay, we're powered up. Now let's see what happens when we actuate these switches. Oh, that one went in one direction, which we didn't touch. I think that one did that last time. Okay, that one went. This one did not go. That one went. That one went. That one's stuck. So I'm setting these in the position they don't want to be, and then we'll go the other way. Yep, that one triggered. That one triggered. You know, okay, contact cleaner did not work. Now we got to look at the electrical signal to see if this thing's actually getting getting the signal to tell it to close. Okay, I soldered 2 wires to the lead, so now we'll be able to hook this up to the oscilloscope and look at the voltage signal that comes in to this solenoid. There we go. I don't know if you can see that on there, but we have a, so there's an interesting signal. We went from that, it went to ground, and then it was a big pulse and coming down. So I think these are these little signals here are probably coupling that unintentional coupling from one channel to another. But that big one, that was it. That's the, what are we at? We're at 66. So this one, that's the, I bet if we went before, it's got to come down. So we're actually not seeing the whole pulse. Let's try to bring some more of that in. Yeah. Okay, so there's a pulse where, let's see, we basically have 20 milliseconds per division. So that's a 40 millisecond pulse where that is coming on to turn it on. Oh, interesting. And this pulse is the, let's move, yeah, so this is, it's the voltage is going up a little bit, and then it's going, then it's pulling it all the way down to ground and then coming back up. I mean, there's clearly something happening here at specific intervals, which makes me think that it's, oh, that one was interesting. It's doing what it's supposed to be doing, I think. These little spikes are probably not that important, but those big ones, yeah, that's clearly a commanded thing. So I think it looks to me like the solenoid driver is working fine. So the electronics are probably doing what's expected.
Okay, after some more thought, I think I have a better idea of what's going on. Looking carefully at these switches, the ones that are broken seem to have a larger movement range than the ones that aren't, especially as they push farther in. Given that a lot of the switches failed all at the same time, my guess is that there is some kind of component mechanical in the shaft that's either let go or got stiff. So maybe there's an O-ring and the rubber got hard, or maybe there's a magnet that's glued on the shaft and the glue failed.
Anyway, I think we're going to have to get into the solenoid to check it out. So I think what I'll do is disassemble it, and then we'll try to probably have to desolder the solenoid, pop it off, and try to see what's going on. Okay, first I'm going to remove these wires that I added for probing. Okay. Now I'm going to take off the magnet. Okay. Magnet's off. Now we can see that we still have, so we got this, without the magnet, this is very happy to go all the way in and out. You can see that it's hooked on to through this bottom of the solenoid here. So I don't know if those pins are going to come out. But let's see what happens when we take out the let's take off the solder first. So for that I need the solder sucker. All right, so we will heat up the solder and try to suck it out of there. Good. Okay. Now we should be able to remove these screws, and we should be essentially free, barring if the solder sucker didn't quite work. Still a little bit of solder holding on. Let's try to get rid of that. Okay, I think the solder is free. So yeah, there it popped right out. Now the question is it being held in by these pins? Yeah, and the answer seems to be yes, although maybe this whole thing can lift out. It's possible this may not survive this, but we know it's broken anyway. Ah, there's a third wire. Interesting. Coming right here. So there's actually 3 wires in this solenoid. I wonder, maybe the coil split. Let's see if we get that one out. There it is. I'm gonna try to put this pin back in. Seems okay. They're definitely spring loaded. Okay. All right, so now we have this solenoid out. You can see there's the 3 wires that were soldered. Okay, well, this part, this little wire, it's just a coil of wire, split coil. There's 3 wires, but the inside part moves completely freely. So it's hard to imagine that there's any friction here that's causing the problem. So I'm just gonna go in here, clean this out, try to reassemble, and maybe I can just get the parts aligned better to reduce the friction. So we'll see how that goes.
Okay, the pins are in. Now I just got to get the wires to go through the correct holes again. Okay. The wires are in place. Now I can put in the screws. Okay. Let's check and make sure we have clean operation. Yep. Okay, it's doing what it's supposed to. So let's see if we can get it to have less friction once we put in the top. Actually, before I close this up, I'm going to get a little Teflon dry lube and I'm going to try to lubricate that shaft. Okay, that feels pretty free. Okay, now I'll put the magnet in. I guess it's possible something happened to the magnet too. Should test it. Okay, looks fine. So let's see. So there's the magnet. See, the part I don't like is that on the working ones, this slot, the back of the magnet doesn't touch the pole piece, which I think when the magnet's touching the pole piece, it's going to have a much higher force required to get it off there. So I wonder if it just got bent or something and we could somehow remove the magnet. I would like it to not basically I can show you what I mean. So this back part here is on this one that is working, is not touching the magnet. There's an air gap in there. It's not big, but it's there. When two magnets are touching each other, it gets much harder to take them apart. So I'm wondering if it's stuck open because there's that gap. So I don't have a good way to change that except brute force. So let's see what happens. Okay, now the magnet is not touching. It still requires it's really not much, it doesn't take much force to open it. But then closing it, yeah, I think I might have just changed the geometry a little bit. Ooh. Yeah, I think I gotta go and get that in a little more. Okay, I have now resoldered the solenoid back in place, and so let's give it a try and see what happens. All of them are closed now, which is what you should get when we're at 121 dB. So now, as we go take the attenuation down, these should start popping open. Oh, this one just popped open at around 10 dB. So that's, whoa, it's working. It's just going in and out. That one's closed, closed, open, closed. Gorgeous. Victory! We have fixed this module. So my guess is that it was that the range of motion got extended a little bit. It was touching the back and it just wouldn't pop in. Now, I didn't touch this one at all and it just started working. So don't ask me what happened there. But I think this one's working. Let's take a look at the next one. All right, I opened up the second switch and I took it off, and
look what I found on this one. This magnet is loose. You can see there's a residue of some kind of glue on the back right there. So I'm pretty sure what happened, as I said O-ring or glue failure. Well, it looks like glue failure. I think what's happening, I tested it, these two are not working. And if you look, I don't know if you can see in here, but this magnet is loose too. And the other magnets that were working are solid. So this looks to be just someone used some crummy glue and over time it just failed. So I'm just gonna glue these back in place and I think we'll be able to get this thing working perfectly again. Okay. So we'll let that glue dry. In the meantime, I'll go fix the other one and then we'll reassemble everything and see if it works. All right, it works. Check it out.
It's alive! It's alive!
Now, we learned a couple things. I actually went and took apart a second one we had. This is a 0 to 62 dB attenuator, and the 30 dBs were stuck. So when I took this one apart, I learned some interesting things. First, these little pins that make contact actually have O-rings on them. On our version, the O-rings were just dust. They were gone and there was no evidence. But those O-rings keep the, are useful to limit the range of travel backwards. So when it's in the open position, the O-rings keep it from getting stuck. So that's why things were getting stuck in the open position. So there's 3 failure modes we found. First, the glue on the magnet fails. That's the easiest one to fix. The second one is that they get stuck open because the O-rings are degraded and you have too much travel in the backwards direction. You can fix that by either replacing the O-rings or by doing the magnet bending that I showed you. The third and the hardest one to fix is when they're stuck closed. I think that's because there's a spring in here and it's probably gotten weaker over time. So what we do, what I did was I got some very thin washers and made like little circlip spacers and stuck them on the shaft. And that limits the travel down here. It seems like a spacer of about 10 thousandths to 15 thousandths of an inch worked, and I got this thing working perfectly. So interesting that there are so many failure modes, but they seem to be working now. So if you like the video, like and subscribe, and we'll see you next time.